Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are moving into the next topic, Hdfs, how to block, replicate, read and write. So we all know what is Hdfs. So it is the important component in the Hadoop environment. So Hdfs is nothing but Hadoop distributed file system. It is mainly used to store the data from the big data environment. So what is Hdfs? Block replication. So block and replication. Blocks are nothing but the smallest continuous location on your hardware drive where data is stored. In general, in any file system, you store the data as a collection of blocks. Generally, the user data is stored in the files of Hdfs. The file in a file system will be divided into one or more segments and are stored in individual data nodes. These file segments are called, we call these file segments as the blocks. In other words, the minimum amount of data that Hdfs can read, write is called a block. So the default block size, as we all know, we are in Hadoop version 3. So mainly we will be concentrating more on version 1 and version 2. So the default block size in Hadoop version 1 is 64 megabytes, but it can be increased as per the needs to change in Hdfs configuration as well. In version 2, the default block size is 128 MB. So replication management. So Hdfs provides a reliable way to store data in a distributed environment as data blocks. The blocks are also replicated to provide the fault tolerance. So that is the main feature of Hdfs, that is fault tolerance. Generally, the default replication factor is 3, which is again configurable. So we all know what is configurable. We can change according to the needs then and there. So when you look into the diagram, so first see in node 1 we have, so this is take for example it is in version 2 Hdfs, so it is 128 MB. So you have in node 1 block 1, block 3, block 4, 5, node 2 block 1, 2, 4, 5, node 3 block 2, 3, 4, block 1, 2, 3, 5. So generally we have in this, we have 5 blocks with 4 nodes. So the replication factor is 3. So this is how, for example, this is how a block will be arranged in the system. The next one, monitoring. So how to monitor whether the data node is available or not. So for monitoring, we have, there is a continuous heartbeat communication between the data nodes to the name node. If the data node's heartbeat is not heard by the name node, that is, if it is not heard after 3 milliseconds, the data node is considered to have failed and it is of no longer available. In this case, a replica is employed to replace a failed node and the change is made to the replication schema. So here is an example of how the working of Hdfs is done. So name node, we have data node 1, 2, 3 and we have blocks, the storage and replication of blocks in Hdfs is shown. So data node will be communicating it to the name node once in 3 milliseconds. If the communication is not done, then it is assumed that the data node is failed. If it is failed, then this has to be employed to, the fail node should be replaced. So the replica will be employed and the changes will be done in the replication scheme. So how is write architecture done in Hdfs? So Hdfs follows warm technique, that is write once, read many philosophy. So you cannot edit files already stored in Hdfs, but you can append new data by reopening the file. Assume that the system block size is configured for 128 MB version 2 default size. So the client will be dividing the file. For example, if the example taught text into 2 blocks, one is of 128 MB and the other is of 120 block B. So the following protocol will be followed whenever the data is written into Hdfs. At first, the Hdfs client will reach out the name node for a write request against the 2 blocks, say block A and block B. Then the name node will then grant the client the write permission and will provide the IP address of the data nodes where the file blocks will be copied eventually. The selection of IP address of data nodes is purely randomized based on availability, replication factor and rack awareness. Let's say the replication factor is set to default. Therefore, for each block, the name node will be providing the client a list of 3 IP addresses of data nodes. This list will be unique for each block. For example, block A, list A, IP of data 1, data 4, data 6. For block B, IP of 3, 7 and 9. Each block will be copied in 3 different data nodes to maintain the replication factor consistency throughout the cluster. Now here the whole data copy process will happen in 3 stages. One is it will be setting up the pipeline. Then the data streaming and replication will be done. After that, shutting down the pipeline by the acknowledgement stage. So here is the first stage, that is setting up Hdfs, that is write pipeline. So before writing the block, the client confirms whether the data nodes present in each of the list of IPs are ready to receive the data node or not. So first write request is made and then the IP address of data nodes are checked. In doing so, the client creates a pipeline for each of the blocks by connecting the individual data nodes in the respective list for the block. Let us consider block A. The list of data nodes available are data node 1, data node 4 and data node 6. So for block A, the client will be performing the following step. The client will choose the first node in the list, which is data node 1, and will establish a TCP connection. And from there, it will connect and data node 1 will establish a connection with data node 4, and then data node 4 will establish a TCP IP connection with the available client, that is data node 6. So this is how the setting up of pipeline does. Once after this is done, connection is done, the data will be streamed from the client node to data node 1. Once the block is ready and it is accepted, it will streamline the data into block A. Afterwards, it will replicate the data that is available to the node 4, then from node 4 to node 6. Now after the replication is done, node 6 will give the acknowledgement to node 4 and data node 4 will give the acknowledgement to data node 1. Hence this pipeline is set up and the acknowledgement is got, so it will delete the IP connection. Next one, data streaming. So as the pipeline has been created, the client will push the data into the pipeline. So you should not forget that in Hdfs, data is replicated based on replication factor. So for block A, it will be stored in 3 data nodes. The replication is always done by data nodes. It will be done sequentially. So next one is shutting down of pipeline or acknowledgement state. Once the block has been copied into all the 3 data nodes, a series of acknowledgement will be placed from data node 6 to data node 4 and from 4 to 1. It will push all the 3 acknowledgements including its own into the pipeline and send it to the client node. The client will now inform name node that data has been written successfully. Now the name node will update its metadata and the client will shut down the pipeline. Similarly, block B will also be copied into the data nodes in parallel with block A. So the following things are to be noticed here. The client will copy block A and block B to the first data node simultaneously. Therefore, in our cases, there will be a creation of 2 pipelines, one for block A and one for block B. The clients write the blocks into the first data node and then the data nodes will be replicating the block sequentially. So read architecture, it is comparatively easy to understand. So the client will reach out to name node asking the block data for the file example doc test. Name node will return the list of data nodes where each block was stored. After that, the client will connect to the data nodes where the blocks are stored. The client starts reading data parallel from the data nodes. Once the client gets all the required blocks, it will combine into form a file. While serving read request to the client, Hdfs selects the replica which is closest to the client. So be aware of that. This reduces the read latency and the bandwidth consumption. Therefore, the replica is selected which resides on the same rack as the reader node if possible. So this is how read architecture is done. Thank you.